We love to see an Allen key set there, an essential tool set for any engineer. You'd be hard pressed to find an Australian rover challenge that didn't have the emergence of duct tape. And it seems like we might have University of Wollongong coming out onto the field for the Space Resources task.
We've seen this team compete yesterday in the post-landing task, and what an incredible display that was, with the very innovative idea of having that second mini rover that they've nicknamed Roo. We're seeing the team utilize some very handy handles there they've attached to carry the rover across over to the Space Resources pitch.
Very scientific with the lab coat there too. Safety is paramount here in the competition as well. All members are required to wear safety glasses and ensure that they're, putting themselves first. And it seems like we've got Roo back out on the pitch again.
I can't wait to see what Roo will get up to today. Just a reminder, this is the University of Wollongong completing the Space Resources task. Their countdown has officially already started as of 10 a.m. local time, and the team is allowed to do any final systems checks and troubleshooting until they're ready to call it. Once they do, all communication between the field team and the base team will be cut off, and the rover will begin operation.
I'd love to get a close-up of that marsupial deployment if we can this morning. We missed that yesterday, and it looked like there might have been a comms issue or something similar with the rover, only to see a second rover appear. Base station team getting ready. Again, the Space Resources task requires a lot of strategizing from the base station team, carefully choosing the sites they prospect so that they can excavate one and process and figure out how much water is inside that sample. Using all of the knowledge that they've learned in the lead up to this challenge about volatiles on the lunar surface, how to even extract something like that, how to determine the water content, really showcasing what they know in the Space Resources presentation. Blues out there, still hard at work, a commendable effort, still plenty of time remaining.
And I really can't wait. I hope we can see this rover in action and a close-up view of those components there. Some really nice blue colors coming out. And I think we've also got some teeth on that end defector on the robotic arm there. So an incredible bold design. There's a nice close-up there of the end effector.
It's great to see teams having a little bit of fun with their rover design. They seem to have a bit of a dinosaur theme going on. I believe it might be a Stegosaurus. And if things don't work out this morning, BlueSat will have another attempt at a task on Sunday with the excavation and construction task. We see some flashing lights there. Still not over yet.
University of Wollongong still to initiate or begin operating their rover here on the second pitch to complete the Space Resources task. I really can't wait to see that mini rover over there deploy and start working. We're seeing what looks like a processing unit there on the rover. So once again, a reminder that these teams will have different subsystems or units that they can attach or detach from the rover or to the rover, depending on the task that they will be completing. So depending on what you need to do, you'll need different units or systems, and that's why the rover will be weighed before each task and before the rover goes onto the pitch.
And with the teams competing just once per day, that really reduces the burden on them as well, so that they have time after they've competed in a task to be able to change over their subsystems if they need to, do some tests, do those checks, and make sure that they're ready to go for the following day. The workshop here opens at 7 a.m. local time, and I would say all of the teams are here in some capacity, working on their rovers from the crack of dawn all the way through to sometimes 8 or 9 p.m. in the evening. The passion from these students is undeniable.
They should all be proud of themselves. We congratulate once again just for being able to come out here and compete. It's an incredible achievement.
And speaking of people who are here from dawn till dusk, our amazing technical committee for the Australian Rover Challenge and the competition organisers, and also many of our volunteer judges too, who have come from industry or our graduates from universities that have competed in this challenge, we thank you for your efforts. It's a phenomenal effort to put together a challenge like this, and it continues to extend its capacity year on year, making it an incredible and fun and enjoyable event for all of the students that come out here.
And there's some of our volunteers that make this event possible. Can we just get a round of applause for the volunteers, for the organisers, for the incredible team behind this incredible competition, running for the 5th time this year.
There are often long days here, out in the heat of the sun, making all of this happen. Now, yesterday we spoke a little bit about the communication systems that some of these rovers use, and Wi-Fi is not allowed in the competition. In real life, we don't have Wi-Fi yet on the lunar surface. It is something that will potentially be available in the future, but currently all communications happen over radio frequency, so we have exactly the same rules here for this challenge. All teams use RF communications of some sort. And unlike Wi-Fi, sometimes this can take a little bit to boot up. So potentially, if as a rover is stationary, it might just be establishing that first comms connection. That can take up to 5 minutes as well. I just noticed, Shagaf, but that is a huge antenna.
Oh, I did not see that. I think it was cutting out of the frame. That's incredibly large. Once again, just the different design approaches to completing these challenges, to getting these rovers operating, ready to go. We can see there at the base station for the University of Wollongong, incredible coordination amongst the team, just teamwork, problem solving. It must be stressful, but it is during these stressful times when the team really shines through, comes together and works together on the spot, which is not easy as well.
Potentially they're trying to get some extra range there with that antenna.
They might be trying to establish a connection, or they might be running with a different issue. We're not entirely sure. And we're still waiting on BlueSat, who still have some time remaining for their post-landing task. Oh, there we go. We have movement from University of Wollongong.
Fantastic stuff. Are they going to deploy Roo? We'll find out very shortly, I think.
I can see some duct tape there around that processing
You're
unit.
right.
Yeah, the very, very valuable tool for every engineer.
our first appearance of duct tape on the track for this challenge. An essential tool for any student in the Australian Rover Challenge. Depositing of some material there for their processing payload.
The team is stepping away from the rover. It seems like that might be a good sign. Ready to go again. Will we see some action from both Kanga, the main rover, and Ru, the mini rover? Really loving the color scheme here as well. That silver on the metal, and then along with that hot pink, it seems, on the wheels, and those connections as well. And I love that both the main rover and the mini rover have that matching color scheme. Just incredible design effort. And there's the BlueSat team from University of New South Wales, who still have 13 minutes for their post-landing tasks, so still plenty of time. If they can get that rover troubleshooted, operating, and on the pitch to attain some points for this task.
I don't know if we've got our roving camera around, but potentially we can have a look in the rover workshop and see the hive of activity that's happening behind the scenes of the pitches. We have a huge number of teams competing in this year's Rover Challenge. That means this activity in the workshop only continues to grow.
There we go. And it seems they've got some successful deployment.
There is a Ru on the ground.
Will we see it in action?
It's backing away.
Oh no, it's taking it with it.
There's the GUI there for the University of Wollongong. Looks like a different setup to yesterday.
Some reliable camera feeds there. Looks like Ru is on the go.
Talking again about the different feedback that teams can get from the systems. It seems like Wollongong are getting signal output and the velocity of their drive motors.
There we go, some action from Ru, the mini rover. I'm really excited to see how Ru can support Kanga in completing the space resources task. Just the different implications, the different benefits that having that secondary or second rover, a second set of wheels, one can say, roving around, cutting down on time to achieve some tasks, covering more space.
There it goes. Ru also has to apply to all of the same rules and regulations as the primary rover.
I don't think it'll have a problem with the weight limit.
You'll see it's got a huge emergency stop button on the back. Should something go wrong.
And a very small, adorable antenna sticking out there. And is that a small LED light at the back as well?
I believe it is. Again, another one of the requirements is having that LED light. Simultaneous
Operation of both Ru and Kanga. Just incredible demonstration here from the University of Wollongong. Coordination from the team there in the base station.
Traveling alongside each other.
What an incredible view. Look at that.
Team of explorers. We spoke yesterday that this idea of having multiple small robots completing either the same task together or different tasks reporting back to a sort of hive mind rover is a whole field called swarm robotics. Hasn't yet been tested on the lunar surface, but is certainly a bubbling field. And to see an idea of this sort tested out here for the Rover Challenge is pretty exciting stuff.
And although it hasn't been tested on the lunar surface, we've definitely seen some applications here on Earth. And one of those is search, life, and rescue drones, where you can use swarm robots, in this case, for drones to go and fight against bushfires, look for people in need of help, people in danger, whether it be bushfires, whether it be even surf life-saving. There is a lot of incredible benefits to having small, modular, and reliable swarm robots that can go out, cover a large area efficiently, and do that for you. So here on Earth, we've seen the incredible benefits, which means there could be so many incredible implications and applications on the lunar surface in the context of space.
You bring up a really good point, Shagaf. We talked a little bit yesterday with Dr. Jason Armstrong about the spin-off and spin-in of space technology, and how the lunar surface is really an extension of some of the extreme environments we see here on Earth. We're talking about deserts and deep seas and places like Antarctica and really remote locations. And by designing for a place like the Moon, one of the nearest remote surfaces outside of Earth for us, it's really a test bed for developing robust, reliable technologies that we can then implement to help communities around the globe in remote regions, and even further do discovery in some of these environments like the deep oceans, much of yet we still don't actually know much about.
And once again, if you're just joining us, this is the Australian Rover Challenge Day 2. We've kicked off from about 9 a.m. this morning, and we've had a range of teams already completing both the post-landing task and the space resources task. And there's a nice view there of the teams hard at work in the workshop.
Testing some subsystems, potentially for a task later today that looks like URT from the University of Melbourne, checking out their robotic arm.
Look at that demonstration there. It's just incredible work.
Potentially even doing a bit of a practice run for the post-landing task later today. Using the precious few hours before they come on. They'll be on the track at 1:45 p.m. local time over on pitch A. So still plenty of time this morning to do testing and troubleshooting of that system.
Back on pitch P, we still have the University of Wollongong just almost at halfway through the space resources time. And we're still seeing some action on the field here from both the main and the mini rover. Will we see some successful analysis, some extraction possibly of the samples, and perhaps even some processing?
The teams will be required to image these sites and save the photos to provide to the judges afterwards. So the points will take a little bit longer to update for the space resources task. We might get them at the end of today, or potentially tomorrow we'll have that updated leaderboard showing.
Just a reminder as well, you can actually view the leaderboard as it gets updated live from your devices if you head to the Australian Rover Challenge website.
And that live leaderboard as well actually showcases a couple of different deliverables. You'll see the updated scores for the post-landing task and also something called a CDR and an SAR. Now, in the engineering design lifecycle, the CDR and the SAR are two critical milestones for any kind of project. CDR being a critical design review where teams demonstrate their complete rover design, talk about how they're going to achieve the design and do their testing to be ready for the challenge. The system acceptance review usually happens towards the end of the project when you're ready to execute the mission and you're going through all of those different systems, confirming what you've completed, how you're going to mitigate any potential risks to your system, and it gets accepted. So teams submitted these deliverables and they scored points for those. And so all of those accumulations of points will be on the updated leaderboard.
And it really goes to show all of the effort, all of the hard work behind the scenes. Really, these teams have been working hard since the last competition, and some for even longer, for years and years of hard work, development, innovation, collaboration, and teamwork. It seems they seem to have somewhat of a lens attached there that they're positioning on that main rover over the samples to analyze the samples. We're seeing some action from the mini rover as well.
Now, I think RU's primary purpose for this mission is to act like a roving camera. It seems like it's got a camera attached on board, a tiny little robotic arm, which can position itself to see what the primary rover is prospecting. Amazing innovation there from the team if that is what it's being used for.
Just giving you that external third party view or third point view of what your rover is doing, which is something we talked about a little earlier today, that the base station team that's operating the rover, once the task has been started, they can only see what they get from the rover from their communications. So just like what you see on the screen there, their live camera feeds and their sensors, that is all they have to work from. So if they are using that mini rover to get that external camera angle, that is an incredible point of view to have as well. We've seen as well with Project Scorpio was this morning that had an innovative way of showing what their rover is doing, and they had multiple camera angles from the top stitched together almost to create almost a bird's eye view of the rover from the top. And they also had a digital twin, so kind of like on the software, on a simulation of exactly what the rover is doing live as it updates, which is just incredible.
Just amazing stuff. So they might be doing some analysis there. Over on pitch A, in just 7 minutes, we're going to have Deakin University setting up to complete the post-landing task. We can see them just outside the pitch, establishing what looks like their base station antenna. It's extremely important to make sure you've got the field of view there to be able to establish reliable communications with your rover as it traverses across the entire pitch. Sometimes, if that's not set up correctly, the rover can drop out as it goes behind some of the pieces of equipment on the surface or reaches into the far corners of the track. So it seems like they might be deliberating that at the moment, making sure that they've got that positioning correct. The last thing you want is a dropout. Great shot there from the University of Wollongong primary and secondary rover.
Incredible traction on those wheels there.
And it's interesting too to see how the design of those wheels is completely different to the primary rover. So they've really had to put some additional thought into this rover being smaller, potentially can get submerged in the regolith. Having those extra treads on the outside compared to the curvature of the primary Kangaroo rover. You can see the tracks that it leaves behind there.
Now, while BlueSat may have had some setbacks this morning, unfortunately, they were not able to come out and have an attempt at the post-landing task. We will be seeing them tomorrow again for the other tasks that are happening over the weekend.
There's still more time to prepare those systems, diagnose what might be happening, get out the multimeter, have another crack.
In the meantime, it is 10:25, so in about 5 minutes, the countdown for Deakin University will begin, who have their Aurora rover set up. It looks like they're almost ready to go right on time on pitch A for the post-landing task. The team there looking optimistic, very exciting. We saw this rover in action yesterday for the Space Resources task, and now we're going to see them attempt the post-landing task.
We should mention too, the base station will be trying to set up in the meantime, and that's always a bit of a rush as well. I've been on the base station team before, and you're standing there in the side wings with your monitors and your laptops and Ethernet cables and power cables ready to go. And then you have to run in and set everything up in that precious time. It's about 5 minutes.
The University of Wollongong there, still hard at work, coordinating, strategizing for the Space Resources task. This is a task where we may not see as much action as we would in the post-landing task, and that's because part of the task is actually prospecting the samples. As you can see here, positioning them over the samples, positioning sensors or lenses or cameras. Part of this task is to actually analyze the samples and identify the one with the most valuable resource, and then potentially as well extract and process that resource to extract those valuable materials or minerals. So they still have 12 minutes, plenty of time completing that Space Resources task.
I saw a bit of a conical device deployed at the front of the rover before. I'm wondering if they've been able to do some prospecting with it. Saving some images there. It's a good sign that they've been able to capture a number of the sites.
Hard at work. Incredible effort by the University of Wollongong. Over at pitch A, we have our second team here coming up to prepare for the post-landing task. This is Deakin University with their Aurora rover that has a beautiful color scheme of black and orange, and those handles there. We talked yesterday about how beautifully clean this design and very neat it is. I'm interested to see how this rover would complete the post-landing task, given its very unique design approach.
This is Deakin rover team from Deakin University over in Victoria. Back to the University of Wollongong there. Roo is potentially scoping out some of the other sites. Again, talking about the efficiency of these missions, they can use this smaller rover to save time to go to future sites that the primary rover will then traverse to once it's done its analysis. That will really cut down on the efforts by the team.
We're seeing that Deakin University has picked up their Aurora rover, and they may have headed back to troubleshoot or check something. Their countdown does begin in about a minute, so once again, reminder for this post-landing task, they have 40 minutes available to complete the task. Up to 100 points are available as well. So a series of tasks and activities each allocated a set number of points.
The field team ready to go on the sidelines.
And their countdown has officially started. So they can take their time if they would like to do final systems checks, troubleshooting, if they need to troubleshoot to make sure the rover is operating, to make sure there's a successful connection between the base team and the rover. But it does eat into their task time. Once they're ready to go, they will call initiation.
So you'll see one of the members with the two-way radio chatting with the base station about how progress on both sides is going.
Probably having trouble hearing the base station team because we're talking too much.
Sorry. Oh, and the next team for the Space Resources task is getting lined up in the wings. That is UQ Space, who have just approached the side of the field, ready to dive in when it's their time. And that will be at 10:45 a.m. local time. So they're out bright and early, eager to get out on the pitch. For anyone who's just joined us here online this morning, you are watching day 2 of the 2025 Australian Rover Challenge here at the University of Adelaide Roseworthy campus in South Australia, Australia. It's a sunny day out here today, just as hot as yesterday, approaching 30 degrees as we get to the highest point of the day, just over 10:30 a.m. local time.
Weather hasn't been very bad this morning. The afternoon might bring in some higher temperatures, but the weekend is looking a bit better as well. So a reminder that this challenge is a 4-day competition. It goes from Thursday through to Sunday with a series of different tasks for the teams to complete. We have a range of teams from across Australia and outside the country as well coming down here to compete. This is the biggest number of teams we've had, and the competition only gets bigger and bigger since it started in 2021 with only 3 teams in the first competition.
So this is the 5th Australian Rover Challenge. And what a 5 years it has been. Just like you said, Shagaf, going from 3 teams to about 20 now. People just can't get enough of rovers.
It's a bunch of space nerds, if you ask me. All right, Deakin University is coming back out with their Aurora rover. It seems they may have been able to troubleshoot and get things ready to go. We're hoping to see some action from the rover here. They have 36 minutes remaining, so only 4 minutes has been cut down. We're hoping to get started soon. Up on the ramp. And once again, the first set of points will be attained if the rover can successfully descend down the ramp and circumnavigate around that lander.
I tell you what, Shagaf, these team members will never have to do arm day again after carrying these rovers around the pitch.
Absolutely not.
50 kilos.
Sometimes up to 90.
Exactly. And they have to be able to show to the judges that they've come up with a way to safely carry it as well. So that's why we see a lot of the rovers having those handles or detachable ropes to be able to carry it.
The team is walking away from their Aurora rover, a good sign that we might see a beginning of an attempt at the post-landing task very, very soon. The descending down the ramp seems like a very simple task, but really requires some very careful movement and some careful thought into the design of the wheels and the weight distribution as well. We did see one case yesterday where unfortunately one of the Rover teams almost tipped over trying to descend down that ramp. So that ramp that you see there, which is representing a ramp that real-life lunar rovers would descend down on the moon, it is only 1.6 meters wide, and there's a 20-degree decline there. So 5 points are awarded to the teams if they're able to descend down and all wheels are then in contact with the ground.
Getting the coordination between all of those drive motors on the rover can sometimes be trickier than it looks, and one of the teams yesterday, when they descended down that ramp, potentially the software wasn't quite doing what it was supposed to, and it essentially collapsed in on itself, which has happened before in previous challenges too. Again, a ramp like this is not something that's very easy to test, so sometimes teams are experiencing this decline for the very first time.
Back to the University of Wollongong here. We're still seeing some action on the second pitch for the Space Resources task, and they just have under 4 minutes remaining. And we're seeing some movement from Deakin University. Down the ramp.
Down.
2 wheels, 4 to go. And that is all 6 wheels on the ground.
Those first points awarded. Let's see where they go next. Now, sometimes you might see a pause when a team has done a drive forwards or backwards. Occasionally, they'll need to switch to a different system to rotate those drive motors for the rover to be able to turn. So if we see a pause, potentially that's what they're doing, or they might be assessing their surroundings using the camera feed.
We're seeing what the base station is seeing now, their live camera feed, a rather different GUI or graphical user interface here to what we've seen with the other teams as well. Again, going back to the different approaches to solving all of these challenges. So many different aspects come together to make these rovers work. It's not just about the mechanical and mechatronic engineers. It's not just about people who are into robotics, but you have people who are specialized in material selection as well, people who specialize in software development, computer scientists to establish that connection, people who specialize in safety, like we were talking about before, with carrying the rover safely, weight distribution, the wiring, electronic and electrical engineers as well. There's so many different disciplines that come together, and as well as geotechnical sciences, as we have tasks here that represent having to extract those resources from the moon, having to analyze that requires that theoretical science of the geography of the geotechnical side of things.
Got that rotation happening. Carefully surveying. This competition is not like other sports, where we're constantly seeing fast action on a field. Sometimes it's these careful, precise movements that end up being the successful way to get the most points. The teams also have to conserve these systems as well, remembering that these rovers have to survive 4 days of endurance. Many different types of challenges requiring sometimes the rovers being assembled and disassembled to swap over payloads. Keeping that suspension intact is a much more difficult challenge than it might appear. That suspension system there working really nicely as the rover goes over some varying terrain.
Incredible navigation of the terrain there. One of the biggest challenges of navigating real-life lunar rovers on the moon, or on Mars, on any other surface that we're not familiar with. You can come into many different types of obstacles. So the design considerations there are extremely critical to ensure that these rovers can navigate through any type of terrain, through rocks, through any obstacles, and even connecting back to autonomy, which is extremely important to increase that efficiency of a rover. If it's fully autonomous, it can even incorporate systems where it can identify obstacles and rove around them with the use of AI or cameras and sensors.
If it approaches some difficult obstacles later, watch how the chassis stays level while the rest of the rover is at different heights trying to get over that obstacle. That is an invention from NASA, the rocket bogie differential suspension system, used on some of the Mars rovers.
Incredible close-up view of the Aurora rover there. Some hot orange flashing from the wheels. A different design to what we've seen already as well.
And time is up for the University of Wollongong competing in the Space Resources task. Fantastic effort today, and we'll hopefully get those updated scores later today or early tomorrow to be able to understand just how well they did.
Incredible effort. Well done to the University of Wollongong. In just under 5 minutes, we're expecting UQ Space on that pitch over there to complete the Space Resources task.
Check out that movement there from Deakin University's rover, Aurora. The second rover, I believe, to be called Rover. Aurora.
Aurora, yeah.
Yeah.
Some of the